Alright class, we're going to take a look now at proofs. And a proof is simply a way of showing that a conjecture is true for every possible combinations of numbers. And so usually when we talk about proofs, right, a proof is an argument using mathematical rules . So an argument using mathematical rules, and often it helps just to think about that as algebra. And logic to show that a conjecture is always true. Alright, and there's that word always. Always true. That means that we don't have to worry about looking at specific examples, because specific examples can be difficult at times. Now, there are a few things that will be helpful when you're doing a proof. It's just some of the algebra terms. Sometimes when you're talking about any number, we might use the letter X. All right? Or if you talk about any square number, right, we'll talk about x squared. Even numbers are multiples of 2. Odd numbers are one different than a multiple of 2. So we can use either 2n plus 1 or 2n minus 1. The terms divisible by, say like 3, 4, 5, would be like 3j or 4k or 5l and so on. It's really important when you're doing proofs that you understand a few things. One of the things is that divisible by, this is roughly the same as a multiple of. And so whenever you see these phrases like divisible by or a multiple of, you always use these forms. The variable that you use doesn't particularly matter in a proof. Often we'll use x's when we're talking about real numbers, and when we use n or j or k or l, we're often talking about integers. So let's take a look at an example here. It says John discovered a pattern when adding the integers. Here you see it. 1 plus 2 plus 3 plus 4 plus 5 is 15. Negative 15, negative 14, negative 13, negative 12 plus negative 11 is negative 65. Negative 3 plus negative 2 plus negative 1 plus 0 plus 1 is negative 5. He claims that whenever you add 5 consecutive integers, the sum is always 5 times the median of the numbers. Prove John's conjecture is true for all integers. Alright, first off, let's make sure we know some of the words here. Alright, the sum, that means we're adding them all together. Alright, 5 times, that's a multiple of 5. And median, median is the middle number. Alright, so in this case the median is 3, and 5 times 3 is 15. Here the median is negative 13. 5 times negative 13 is negative 65. Here the median is negative 1. 5 times negative 1 is negative 5. Let's go about proving this. Alright, so let's pick 5 consecutive integers. Alright, and starting with x, that'll be the first one. The second one, you add 1 to it. The third one, you add 2, then you add 3, And you add 4, and I think that gives us 5. 1, 2, 3, 4, 5. Right, notice, we've used algebraic expressions to talk about the 5 integers, and that way we can talk about all integers without having to look at a specific examples. All right, next we're going to do what John told us to do. We're going to add them. All right, so we're going to add those 5 integers together. And using our algebraic operations, we've got 1, 2, 4, 5 x's. And 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. So our expression will always be 5x plus 10. And if we factor out the number 5, we get 5 times x plus 2. And notice, x plus 2 is the median. So this is 5 times the median number. So no matter which 5 integers in a row that we pick, we will get 5 times the median number. All right, and that means our proof is finished. All right, so we used an algebraic argument without specifying any of the 5 numbers to show that we get 5 times the median number.